Characteristics. It consisted of six basic instruments of an airplane: cockpit, pilot statics instruments, speed indicator, anemometer, altimeter and vertical speed indicator, variometer, gyrospeed instruments, altitude indicator, artificial horizon, tour coordinator and direction indicator gyro. Purposes: the fly under instrumental flight rules (AFR) when not to control the aircraft simultaneously as we read charts, turn on the radio, and perform various complex tasks. For a successful AFR flight, it is necessary to complete a reasonable interpretation of the instrument, which will help us take the correct action to maintain control of the aircraft. Instruments are categorized according to their method of operation, while the static pilot system instruments are necessary for any flight. Gyrospeed tools are suitable for VFR flight, but essential for AFR flight. Rigidity in space. This property can be explained simply and applying Newton's first law, which states that a body at rest will remain at rest, or if it is in a straight line, it will remain in a rectilinear motion, unless an external force acts on it. Perception is the action of resulting deflection in a rotating whirlwind and deflection force is applied to its edge. If this force is used, the resultant force will appear rotated 19 degrees in the direction of rotation and the applied force direction. This effect is called perception. Altitude indicator. Artificial horizon. We can consider this instrumental as the mechanical substitute for the natural horizon. It is the only instrument that gives us immediately and directly information on our pitch and roll. This instrument will be an essential part when we perform a cross-check of the tools as we will use it to make adjustments without visual reference. Heading indicator. A gyro leading indicator is required to flight EFR. It is our primary recourse for controlling information, since course changes in a coordinate flight imply that the wings are not level. We can indirectly say that its rails indicates bank. Classic throw indicator. This could be thought of as inclinometer. The ball located at the bottom of the instrument's remains centered, while flying straight and level due to gravity. If the turning forces are unbalanced, the ball will roll in the excessive force direction, indicate and skip or slip. At the same time, another shock their turn radio allowing of the see if we are making a standard turn or not. Turn coordinator. Instead of the needle, these instruments track the plane's movement around the launch aids, displaying a miniature airplane. The motion of the aircraft is proportional to the rate of turn, the conventional inclinometer. The ball is also part of this instrument. Static picture system. The static picture system instruments are based on air pressure difference to indicate speed and altitude. The impact pressure, also called dynamic, is the pitted tube pressure is only connected to the speedometer. The static or ambient pressure obtained from the stakes intake is related to the two instruments that make up this system. Speed indicator. It is the only instrument that uses both static and impact pressure for in operation. The indication is determined by comparing both strengths. The greater the difference, the greater the speed. The speedometer is divided into several color ranges that define range of rates. for the different flight prices. Indicated IAS. It is read directly from the instrument without any correction. Calibrated CAS. It is the indicate speed corrected by instrument and installation error. This error is generally hid at lower rates, usually while in the correction valves in the POH of our aircraft. Through tests, calibrate speed corrected for temperature and air density. Remember that at high altitudes the density decreases. The thrust increases as we ascend while the EAS falls. Ground GS. The actual speed correct for wind. If we fly with a headwind, our GS will be lower than the thrust, while if we do it with a tailwind, the GS will be higher than the thrust. Altimeter. The altimeter is an unrelated barometer that measures the atmospheric pressure at the level where we fly and presents an altitude infrared. It uses static pressure for in operation. Remember that it becomes less dense as we ascend. The higher the altitude, the lower the stretch. This pressure difference at various levels cause the altimeter to indicate size changes. The cause or pressure changes directly affect the indication accuracy. The altimeter has a knob for adjusting the scale. Vertical speed indicator. This instrument uses static pressure to indicate an ascent or descent in feet per minute (APM). As the aircraft ascends or descends, the device determines the vertical speed by measuring how fast the air pressure increases or decreases. If the air pressure increases, the descent will be indicated if the pressure decreases. It will mean a climb if the pressure remains constant. The indication will stay at zero. Cross-check. It is the correct division of attention and interpretation of the flight instrument. Attention must be effectively divided between the instrument in such a way that the instrument can be covered, determining the exact altitude of the aircraft product of the different errors found during a flight, such as human error, instrument error, and variation of aircraft performance under other atmospheric and weight conditions.
Activar el sector de micrófono y, por ejemplo, para escuchar aquí pues, para un código Morse, ¿vale? Una DF, radio ayuda también. Se sintonizarían aquí un NDB. Ya lo iremos viendo, como digo, muy por encima. ¿Vale? El iluminador. Esto es para iluminar de noche el pedestal. ¿Vale? El Flood Bright and Panel Bright. Es decir, el Flood Bright, lo que hace el Flood es como, digamos, Flood en inglés sería como la luz general, ¿vale? O sea, la iluminación general, y el Panel Bright pues sería para iluminar, no sé si lo veis, los paneles, ¿vale? Los paneles. Y el Flood lo que hace es la iluminación general, ¿lo veis ahí? Sí se ve bien, sí, empieza de día. Vale, siempre que veáis Flood, acuerdo, en Boeing es para la iluminación general y luego el Bright es para los panelcitos. ¿Bien? Ahí lo veis. Bueno, seguimos. ¿Veis? Fijaos que Boeing tiene aquí, digamos, una pequeña descripción de cada panelcito. Este caso para cargo, de fuegos, testeos y demás. Weather Radar, ¿vale? Para tener, activar y gestionar desde aquí el Weather Radar que vamos a ver en el Navigation Display, ¿vale? Todo lo que toquemos por aquí, todo lo que toquemos, todo lo que configuremos aquí, vamos a verlo reflejado en nuestro Navigation Display, entre otras cosas, igual que va íntimamente relacionado el poder ver al sintonizar un board, ¿vale? El nombre del board aquí abajo y las millas, si tuviéramos, ¿veis? Las millas. con, si tuviera el BOR, un DME. Aquí tendríamos las millas y el BOR, el nombre del BOR. Ahora voy a mirar un momentito el BOR de Palermo, va. Vale, ya acabo de ver, 113.0. Bueno, entonces vamos a poner BOR de Palermo.
Electronic Centralized Aircraft Monitor, an engine indicator of the crew alerting system ACAS in Boeing, and the Electronic Centralized Aircraft Monitor ICAN in Airbus is an integrated system of the in-modern commercial aircraft to provide the crew with information of the operation of the engines, other systems, and messages to the pilots. In aircraft equipped with ACAS, the required corrective action is called a checklist. The system provides us with the instrumentation of various engine parameters, including, for example, RPMs, temperature values, fuel flow and quantity, oil pressure, among others. The other aircraft systems controlled by ACAS are hydraulic, pneumatic, electrical, de-icing, control or surface systems, which replace all analog motors with software-driven electronic displays 0. Superior ICAN. In this case, as there are two screens, we will mention H1 first, the central part, the upper screen, called Engine Warning Display, AWD. Above shows the primary engine data and other information. For example, flaps and slats, configuration, AOR, AGT, number 1 and number 2, fuel flow, messages, and checklist in relation to operation normal. Lower icon. Second, the lower screen, called System Display SD, is the secondary screen. It presents permanent warnings. That is, it offers additional information, which includes system damage and its consequences, either automatically or manually. It displays the following. Additionally, engine indication, fuel used, oil level, oil pressure and temperature, engine vibration levels, and fuel and oil filter clogging warning, in addition to cruise page, pneumatic system, bleeding, and air, bleed air, cyst, electrical cyst, hydraulic cabin pressurization, cyst, fuel, APU, air conditioning, doors and oxygen system, flight control, landing gear. Does the airplane autopilot work? Although pilots have the automatic pilot function, which has a significant presence in different phases of the flight, manual mode is mandatory during the takeoff phase and while parking at the destination. Some aircraft, like the A320, are equipped with two autopilots. The rest of the phases can be managed by the autopilot as long as the aircraft pilot supervises it. In any case, the autopilot never does anything on its own or intelligently, but always performs basic tasks that the pilot commands at his discretion. In the phases in which the autopilot is active, the pilots are in constant contact with the air traffic controllers. In this way, flight parameters such as height, speed, or heading of the aircraft are adjusted. This information allows the aircraft systems to assimilate the information and incorporate it along the way. Autopilot parameters. The different information that is provided to the system fits other device and allows maintain altitude. The pilot raise or lower the aircraft based on the information they exchange with the controllers. By incorporating this information into the system, the aircraft will climb or descend to the desired altitude and remain there until the following modification. Second, schedule and stay on course. Using a flight management system associated with the automatic pilot, the aircraft route can be automated. Thanks to this, the aircraft is allowed to improve accuracy. 3. Navigation. Through the flight mentioned above, management systems and once programs to perform the flight. The plane will follow the program route with great precision through the automatic pilot. All this reduces the possibility of errors that could occur while flying manually and being a great support to the pilots once programmed by the pilot. It marks the route followed in the same way that a car's GPS can't do. 4. Approach instruments. It allows to the pre-program the device for the approach to the airport. It will enable having a greater situational awareness and concentration of the pilot, since there will come a time before landing when they will have to return to manual mode. Autopilot buttons and controls. Some different buttons and controls operate the automatic mode of the some function. We explain what some of them are. 1. To improve route control. 2. FD navigation display. 3. HDG indicates the heading. 4. Navigator. 5. Alt tells the pilot how to track the altitude. 6. HDG now to control the direction. 7. APPR for the approach. 8. LBL keeps the plane level. 9. Is PD modes. Activate speed control.
Radio Management Panel. The tachometer gauge is a meter of revolution per minute (rpm), which it represents on a dial calibrated from 100 to 100 rpm, with significant marks every 500 rpm, and that's it. It does not require power from the aircraft. In aircraft with the fixed pitch propeller, this instrument provides the RPM number of the engine crankshaft and by station of the propeller on airplanes with a variable pitch propeller. It indicates the propeller's number RPM. Some tachometer indicators are expressed as percentage, to which 100% represent the maximum engine revolution. These indicators can be the following. Indicator number 1. Used for turbofan engines, they indicate the revolution in percentage of the fan blades and the first compressor stage. That's it. The low pressure compressor. Number 2 gauge. Number 2 represents the high pressure compressor rotational speed and is displayed on the gauge as a percentage of design RPM. The high turbine governs the high compressor and concentric axis connects both. Indicator NG. Used for turbopropeller engines, it represents the revolutions of gas compression of the engine, generally in PT6 engines. An edge indicator indicates the number of revolution of the engine reduction section and the relationship with the proper RPM for turbopropeller engines. Manifold intake pressure indicator. It is used in conventional engines with the variable pitch propeller. Is a barometer that measures the pressure of the air-fuel mixture in an intake manifold or manifold and displays in units of inches of mercury. This indicator informs the pilot of the engine power the higher the pressure. The throttle controls power through the manifold or manifold's intake pressure, which is registered by the intake pressure gauge. The greater the gases opening, that higher intake pressures, and therefore the greater the power developed by the engine. Indication of engine thrust. Engine pressure ratio EPR, turbine discharge pressure or exhaust nozzle pressure. This instrument indicates the pressure increase between two stages of turbine engine. The EPR system is designed to compensate for speed and altitude on the measurements taken automatically. Torque gauge turboprop engines, because only a tiny part of propulsive force produced by a turboprop is due to the jet thrust. Neither the turbine discharge pressure nor the engine pressure ratio is used to indicate the power the engine is producing. Instead, a torque meter is used to measure the level of control the engine is developing on the ground and in flight. In most systems, the torque gauge oil pressure is used to actuate a torque gauge oil pressure gauge instrument proportional to the engine power in pounds per square inch. Some torque gauges are calibrated to be read in the terms pound-feet of torque, and some can be read in shaft horsepower directly. Engine temperature. Piston engines have two temperature indicators. Gas outlet temperature indicator EHT indicates if the airflow mixture has the correct proportion. This ratio is adjusted with the mix control. If within a variety, the temperature set by the EGT goes up, and when the enriched it goes down. The cylinder heat temperature gauge CHT indicates the engine temperature typically measured at host cylinder and the engine, the one furthest from the cooling intakes. Primary flight screen. The PFD or primary flight display is the screen that shows us the information of the primary flight instruments, the navigation instruments, and the flight status in a single integrated screen. In some cases, they include information on an engine or engines and other secondary systems. However, we try to present these screens following two main criteria: priority and customs. According to priority, we can see that the attitude indicator in these systems is the one that is usually the largest and is located in the center of the screen. This is certainly not by chance, and this indicator is motor instrument. In other words, the control of the aircraft is essentially part of it. Now, on the left side of it, there is the speedometer, and on the right is the altimeter. This responds to the custom that is has regarding the location of these instruments in the analog system. However, utilizing module types has radical change in the way these two instruments are shown. Secondary flight screen. Electronic Flight Instrument System EFIS. EFIS features external GPS receiver with the Jepsen database, the external remote compass system, horizontal situation indicator, resolution equipment interface, ARINC 429 interface, at least one transmission channel and two reception channels, autopilot interface, GPS interface, instrument landing system interface, navigation interface, altitude encoder interface, battery for the emergency power. The connection harnesses must comply with the military standard. The EEFIS includes an HSI display that shows hidden indication, hidden deviation, vertical direction, track over the ground, ground speed, altitude, distance to waypoint, to front indicator, the descent path indicator, and descent path signal. The GPS data overlay includes text screens that display various information in text format. Text display includes track over ground (TRK), hearing CRS, ground speed (SPD), distance to next waypoint (DTW), and up to two direction indicator selection.